This video is a review for the transformations test. So in 1, 2, and 3, we want to name the rigid motion. So here we have an apple and another apple that was turned. So this is a rotation. In number 2, we have a penguin and an upside down penguin. So the penguin was flipped. So this is a reflection. And in 3, we have a dog that was moved from one spot to another, which is a translation. Describe each translation using coordinate notation. So remember, coordinate notation is when we have x to y arrow, and then we have x plus or minus a number, and y plus or minus a number to represent the movements. So in number 4, each point moves right 20 and up 7. So we would have x comma y arrow. When we're going right, we're going to add to the x, so x plus 20. And when we go up, we add to the y, so y plus 7. Then we want to know what coordinates of the image -4, 1, and what quadrant does it lie in. So we are going to put -4 in for x and 1 in for y. So we would have -4 plus 20 and y plus 7. So that is going to get us the coordinate of 16, 8. Both numbers are positive, so it is going to be in quadrant 1. In number 5, every point moves down 25, so we're going to have x to y changes. There is no left or right movement, so we're going to leave it as an x. And then we have y minus 25. So when we put in our coordinates, we would have 2 for x, and for y, we would have 11 minus 25. So our coordinate would be at 2, -14. When the x is positive and the y is negative, that is going to be in quadrant 4. What are the coordinates of the image of g -3, 7 after a reflection over the x-axis? So remember that on a coordinate plane, the x-axis is our horizontal line. So if I have -7, 3, that's going to be somewhere over here. So in order to flip it over the x-axis, we know that we are 3 units away from the x-axis, so we'd go 3 the other direction. So that new coordinate would be -7, -3. So all you're doing to flip over the y-axis is to change the sign of the y-coordinate. In number 7, a dilation of 9 to 3 maps to 3 to 1. What are the coordinates of the image of 6, -12 under the same dilation? So if I want to look for my scale factor, I can take a coordinate from the new point over a coordinate from the old. So I'm comparing the x coordinates, which is 1/3. So I'm going to multiply the coordinates 6 and -12 by 1/3. So my new point would be 2, -4. In number 8, a figure is translated 5, -9, so right 5 and down 9. Which translation would move the image back to the original? So we want to do the opposite directions in order to get back. So we would have -5 so that we could go left 5, and then +9 so we could go up 9. Perform the series of transformations. So in number 9, we want to reflect over the y equals x line. So the y equals x line is our diagonal line. So what's going to happen here is that you are going to switch the x and the y coordinate. So if s is currently at -5, 4, the new s coordinate is going to be at 4, -5. B is at 1, 3, so the new coordinate is going to be 3, 1. And Q is currently at -6, 1, so it is going to be at 1, -6. In number 10, we want to rotate 90 degrees clockwise about the origin. So remember, every 90 is a new quadrant, so we will end up in quadrant 1. Our rule then is that we change xy to x comma to y comma negative x. So what's going to happen is that means we're taking the opposite sign of the x coordinate. So for A, the current coordinate is -4, 7. So when we switch the order and make the x now a positive number, it's going to be at 7, 4, which is in the first quadrant. B is at -8, 7. So B prime is going to be at 7, 8. C is at -8, 1. So C prime is going to be at 1, 8. D is at the coordinate -4, 1. So D prime is going to be at 1, 4. And then that would complete our box. In number 11, we want to change x to y to x plus 2 and y minus 3. So that means for every coordinate, we are going to go right 2 and down 3 because this is a translation. So from C, we would count right 2 and down 3. That's C prime, right 2, down 3, A prime, right 2, down 3, T prime. And then we can connect our shapes. In number 12, we have a half in front of both coordinates. So that means this is going to be a dilation with a scale factor of 1/2, which means it's a reduction. We're making a smaller shape. So right now, D is at -6, 2. So when we take 1/2, D prime is going to be at -3, 1. O is at -6, -8. So O prime is going to be at -3, -4. And G is at 6, -2. So G prime is going to be at 3, -1. And then we can connect our points to form our triangle. In number 13, we want to reflect over the x equals -2 line. So x equals -2 is a vertical line. So we count how far we are away from the line and go that many the other direction. So S is 2 away. We go 2 the other direction. That's S prime. R is 3 away. So we go 3 the other direction. That's R prime. And Q is 4 away. So we go 4 the opposite direction. And then we can connect our points. In number 14, we want to rotate 180 degrees counterclockwise about the origin. So XY is going to stay in the same order, but is going to switch the signs. So A is at 9, -2. So we switch the signs. We're now at -9, 2. B is at 10, -4. So when we switch the signs, B prime is now at 10, -10, 4. C was at 6, -6. So C prime is going to be at -6, +6. And D was at 2, -2. So it is now going to be at -2, 2. So we connect our points. In 15, DEF is enlarged to ABC. So going from DEF to ABC, and it is enlargement. What is the center of dilation? So if we look at the lines, they're all going towards where the x-axis and the y-axis cross. So that is going to be the origin, 0, 0. For scale factor, because we are going DEF to ABC, we want 18 over 10, which is going to reduce to 9/5. We want it to be the bigger number on top because remember, it is an enlargement.